Hello guys, welcome to CV Guide. Hope you liked my last Eurocode video in which I gave you the basic knowledge about SS EN 9090. In last video I explained about the basic parameters of 9090 which I will use in this video as a load combination. So if you have not watched my last video, then I request you please watch my last video, then watch this video. Otherwise, this video will not be useful for you or you will not be understand properly this video, right? But here I give you the summary what we learned from the last video. I gave the basic overview about the Eurocodes, then design life, safety class and safety factors, then action, what kind of the action, permanent and variable action, representative value of variable action, and five value of the different variable action. Why I'm saying to watching my last video? Because these all things I will use in making the load combination. So if these terms are not clear to you, the load combination concept will not be clear to you, right? So in this session, I will cover the totally load combination points. Load combination set A, load combination set B, and load combination set C. And then after that, I will give you the small example also how we make the load combination. So you will get the basic understanding about the load combination. So before understanding the load combination system, we have to understand how we use the variable load in our load combination system. Suppose what is the variable load? Variable load might be any kind of load like overload, traffic load, wind load, snow load, or braking load, other kind of the etc. There are a lot of variable loads. So in this variable load, when we make the load combination, we consider only one load as a main action load. Mind it, we always consider only one load as a main action load, and other load is the associated variable load with the main action load. And every time, suppose if first time you have considered overload as a main action load and other four is the associated variable load with the main action load, then next time what will be the other combination? We will consider traffic load as a main action load, then other four load is the associate variable load with the main action. Third time we'll consider the wind load as a main action load and other load is the associate variable load with the main action. We do this because any time any kind of variable load might be give the worst effect. We will do this permutation combination with all the loads. This associate variable loads is always multiplied by the one reduction factor which we call as a phi, and how we use it I will explain in the next slide. So generally in Eurocodes we have three set of equation. First is the set A. We use the set A equation to check the structure stability like sliding, tilting, right? And in this you can see this is the equation 6.10a. There are permanent load might be unfavorable and the favorable. If the permanent load is the unfavorable, then there is the different coefficient. Is the favorable, then there is the different coefficient. For example, you are designing a retaining wall as a cantilever retaining wall. In the cantilever retaining wall, your retaining wall cell weight is the favorable load to check the structure stability. So in that case, we take the minimum coefficient, right? So permanent action, we always take the coefficient our need basis, and here is the coefficient is written. You have to read it properly. And same is the leading variable. Now you can see why I explained in the previous slide is the leading variable load. If you have four or five leading variable loads, you have to consider one load as a leading variable load like gamma q1 and qk, and the other loads will be multiplied by the gamma q. Gamma q coefficient is mentioned here, and phi 0, this phi coefficient I mentioned in my last video for the different category loads. Is the traffic loads, is the building loads, then I mentioned all the tables in my previous video. So if you have not watched that video, please watch that video, then only you can understand this load combination system. So now you can understand, if you have three or four variable loads, every time you have to consider one load as a leading variable, then other load is the associated variable load with the leading variable load, right? So you that way you can make three or four or five time a combination if you make the permutation and combination like that, right? So in my last video I mentioned that every country has their separate national annexure also, and if they have changed the value of coefficient in their national annexure, then you have to choose their national annexure value. For example, if you are doing project for the Finland, so you have to check the Finland country national annexure also, is there is any change in the coefficient. If you are using Swedish project, if you are using Germany project, then you have to check their national annexure also to find the exact coefficient. For example, I generally design as a Swedish project. I have just put the how the this coefficient varies. So if you compare my this table to Eurocode table, so you will see there is a change in the coefficient values. So when I design for the Swedish project, I use only this coefficient. I take the reference as a Eurocode, but I take the load coefficient values from this table, right? Same is the load combination is the set B. So if you are designing your project as a ultimate limit state is the design forces when you are finally calculating your reinforcement. Then there is the equation 6.10a and 10b, right? The 6.10a 10b is a part of set B. So what is the difference in 6.10a and 10b? There is nothing much, but there is no reduction factor in equation in the cell weight of the equation 6.10a, but in the leading variable, main variable, you multiply with the psi 0 and the other variable loads like psi 1, psi 2, psi 3, right? But equation in the 6.10b, you have one reduction factor in the permanent load also, zeta, right? But in the variable loads, in the main leading load, you have full coefficient gamma q, no reduction phi factor, right? And for the other variable load is the same is the phi 0, phi 1, phi 2, phi 3. And this phi 0, phi 1, phi 2 value from where you will take? The tables which I pasted in my last video, right? So you have to choose this psi value from there, right? So always when we design the structure, we will make the equation according to 6.10a also, and we will make the equation according to 6.10b also, and we'll see what is the worst values. Whatever the worst values comes, we use those values for the design as a design forces, and we calculate the reinforcement for those forces, right? So these the all coefficient value is given here. But same, for example, I have put the Swedish national exchange values also. So you can see there is some coefficient changes here in this table. If you compare this table to Eurocode table set B, so you will find that there are some coefficient changes. So whenever I design any project for the Sweden, I use this table as a set B, right? So you are designing for any other country, you have to check their national annexure to making the load combination. Concept you have to take from the Eurocode, but you have to check their national annexure also. If there is no change, then take the coefficient from the Eurocode. Otherwise, if there is any change in the coefficient value in your national annexure, then you have to take national annexure's value. Same set C. Set C generally we use for the geotechnical load only, right? Where is the like retaining wall, earth pressure. So this set C here N is the structure geo set C. So we use only this equation for the geotechnical loads. So here also favorable, unfavorable, and maximum minimum coefficients also. And same is the leading variable and complying variable action. Leading variable you have coefficient. So here you can see for the leading variable gamma q is 1.25, 1.3 for the different situations, right? And the other is again we multiply with the psi 0, psi 2, psi 0, psi 1, psi 2, right? So this set will use only for geotechnical. And why we use this load combination for the geotechnical, then I will explain in my next video, right? Why this equation is worst in case of the geotechnical load, then you will understand clearly why we use this equation for the geotechnical load combination or geotechnical loads. Same, if I go in Swedish national annexure, there is change in the coefficients value. Whenever I design my project for the Sweden, I use this coefficient values. So if you see my previous slide, there was coefficient value 1.3 or something like that. But if I use, there is clear value 1.4 I have to use. So that is a clear guideline for me for the Swedish project that I have to use 1.4, right? Same is the load combination for the accidental and seismic, right? So you have same. unfavorable and favorable, there is no coefficient here for the accidental and seismic load. And for the accidental load, there is no coefficient, uh, like no safety coefficient. Whatever the accidental load, we apply this directly, and the other accompanying load we multiply by the psi 1, psi 2. So here you can see we will not use psi 0 directly. We will use psi 1, psi 2 in case of the accidental load, and in case of the seismic we directly use the psi 2, right? So you have to read this all clause also below the equations. So where what things we have to use in what case. So here explained properly. Same is the combination for the characteristic, frequent, and quasi-permanent, right? So same thing for the favorable and unfavorable. There is no coefficients, right? And for the leading and other variable loads, for the characteristic value, we have leading variable, or for the other one, we multiply by the psi 0. For the frequent, we directly multiply leading load as a psi 1, then other load psi 2, psi 3, continuous. It depend on whatever the how many variable loads you have. But generally after psi 3, your psi value is generally 0. So we we can take only 3 or 4 variable load in together. Rest of the variable load will value will automatically 0 because their psi coefficient will be equal to 0, right? So here you can also see the Eurocode. In Eurocode also they have written the next and next may also refer to the infrequent combination of the action. That means there might be some changes in the coefficient value in the next and next also. So now here I have given just one example as per the load combinations value how you have to use. For example, I have taken the safety class 2. So I have made this load coefficients value as a safety class 2. So as per the Swedish national annexure, the safety class 2, the gamma D coefficient is the 0.91. So here I have mentioned safety coefficient 0.91, right? Now, so for the self weight, if I go as per the equation 6.10a, the value will be 1.35, then permanent load, or the minimum value is in case of the favorable, there will be coefficient of the 1. Same is the earth pressure. I told you for the geotechnical loads we use the set C. So here I have used the coefficient 1.1, right? And pressure is the permanent load, but I have used the set C for here because it's a geotechnical load. Shrinkage load I have used 1.35, and this is the safety class value. Variable load, suppose I have three variable loads. So for the leading variable load 0.91, 1.5, psi 0, because in the equation 6.10a your leading variable will be multiplied by the psi 0, right? And this is your variable load, leading variable load value. The other variable load again with the multiply by the safety class factor, then 1.5 into psi 1, then second variable load 1.5 multiplied by the psi 2, right? So this go like this. Then next time you have to make 3 or 4 combination. Like next time you have to load variable load 1 you have to consider as a leading variable load, then other two variable load is the accompanying variable load. Then next one, this leading variable other variable load 2 you have to consider as a main load, and the rest 2 is the accompanying variable load. So you will get 3 or 4 equation like that, and you have to find worst value. So now in this slide we'll see if the same with the same loads, if we have to make load combination as per the 6.10b, then there will be only coefficient change as per the equation 6.10b. For example, self weight, the safety class factor will be remain same, but there is an additional reduction factor zeta in the self weight load coefficient 1.35 multiplied by the zeta. This zeta value can be different in the different action and annexure. Earth pressure, as I told you in the previous slide, is a geotechnical load, so we'll use set C coefficient, set C equation coefficient. For the shrinkage, so your safety class factor will remain same, and your 1.35 factor will multiply by the zeta also and your load value. And for the mean value, there will be the same coefficient. For the variable loads, your safety class factor will remain same, but only change here that your main variable load will not be multiplied by the any psi factor. Your main leading variable load in equation 6.10 be directly multiplied by the 1.5 without any reduction factor. So that is the reason generally equation 6.10b forces are more worst, but we have to check both case equation 6.10a or 10b. We don't know what which case can be the worst. We have to check the both cases. As per the experience, generally 6.10b cases is the worst, but we have to check both the cases equations. Then other variable loads, same is the 1.5, then multiply by the reduction factor psi 0. Variable load 2 multiply by the reduction factor psi 1, and multiply by other variable load 3 multiply by the reduction factor psi 2, right? And your loads. So and after that we'll make the same permutation combination. Like first, then in the next case you have to consider load 1 as a leading variable and other three load as a complying variable load. Then in next case, load 2 you have to consider as a main leading variable load. Then other 3 is a complying variable load. So you will get 4 to 5 equation and you will find worst value, right? And you have to design accordingly. So guys, hope you have understood this load combination concept clearly. And if you have any doubts, don't hesitate to comment. You can comment in my YouTube channel. You can contact me on LinkedIn chat box. I will answer you properly. Thank you guys. Thank you so much.